Hello everybody, it's Miss Austin and I'm going to be doing the Unit 4 Lesson 10 problems. You might be doing these on Desmos, you might be doing these in your book, you might be doing them on the digital PDF. But here we go. We are skipping number 1. That one isn't even in the Desmos activity. And I think in Desmos this one's actually first. So we'll just know that. So it says, the sun is 62 degrees above the horizon. A tree casts a shadow that is 12 feet long. So we've got, here's the sun, right? And it's 62 degrees. So this is 62 degrees right here, same, right? Angle of elevation or angle of depression. How tall is the tree? All right, so we've got our 62 degrees, that's my opposite side. And the 12 is my adjacent side, which is tangent. So the tangent of 62 is, I don't know, over 12. Put a 1 under this. X equals the tangent of 62 times 12. Go to my calculator. Tangent 62 times 12. The tree is approximately 22.6 feet tall. If you're not getting that answer, I better make sure my calculator, make sure your calculator's in degree mode. Number 3, a plane leaves the ground, so with an angle of elevation of 6 degrees. So here's the plane. The plane travels 10 miles horizontally. How high is the plane at that time? Okay, so by the time it travels 10, it wants to know how high it is, so it wants this distance right here. So we've got 6 degrees, we've got opposite, and we've got adjacent, which is tangent again. So we've got the tan of 6 is x over 10. X equals the tangent of 6 degrees times 10. Type that into my calculator. The tangent of 6 times 10. The plane is approximately 1.1 miles vertically. It's right here right now. What is the distance of the plane's path? So now they want me to find this, right? The hypotenuse is path. So I got a couple of choices. I could do Pythagorean theorem. I could do trig again. I'll do trig, right? So I want the hypotenuse. So I have adjacent. I'm going to use the one they gave me, and the hypotenuse. So that's cosine. The cosine of 6 degrees is adjacent over, I'll call that the hypotenuse. Put a 1 under this. That's 10 equals the cosine of 6 times h. I'm going to divide both sides by the cosine of 6. So type that into my calculator. 10 divided by the cosine of 6. The plane's path is about 10.1 miles right here. So this is 10.1. This was about 1.1. All right. Number 4. On Desmos, there's a table here that helps you do this. It says find the missing measurements. So first of all, it doesn't matter what order, I'm going to find this hypotenuse, which would be side AD. I'm going to do Pythagorean theorem. You could find the angles first and then do trig. You could do whatever you wanted. So I'm going to do 3 squared plus 10 squared equals, I'm going to call this little b. I don't know squared. So that's 9 and 100. So 109 is b squared. I want to know what b is, not b squared. So that's going to be roughly, use my calculator, take the square root of 109, about 10.4. So right here, this is 10.4. And it should be the longest side, right? Now I need to find the angles. Now to find the angles, I'm not going to use that side I just found. I'm going to use 3 and 10. So this angle, angle A, I'm going to use opposite 3 and adjacent 10. So opposite and adjacent is tangent. So the tangent of A is opposite over adjacent. This time I have to undo, right? I'm going backwards. I know the two sides. I want the calculator to tell me what angle has that opposite over adjacent. So you type inverse tan of 3 over 10. And depending on your calculator, hopefully you've been practicing, you know how to type that in. If you don't, please ask. So it says this angle is approximately, we're going to round to the nearest whole degree, 17 degrees. Now, do you have to go through all that work to get B? No, because triangles add up to 180. That was already 90, so these two have to be 90. So this guy's going to be what, 73? I mean, we could make sure. Let's do it one more time. If I do this angle and use 10 and 3, opposite over adjacent, that would be the tangent of C is 10 over 3. So inverse tan of 10 over 3, let's type that in. It should be about 73 degrees. It's going to be rounded, right? Yep. Oh, that was D. Sorry, guys. I thought that was a C. D. So 73 degrees. And I could have just got that by subtracting from 90. We got angle D is 73, angle A is 17, and this missing side is 10.4. Number 5. Ramps in a parking garage need to be both steep and safe. The maximum incline for a ramp is 8.5 degrees. Is this ramp safe? So we need to figure out what this is. It says that the maximum it can be is 8.5. Well, let's figure out what that angle is. I've got opposite and adjacent. That's tangent. The tangent of, I don't know, is 20 over 100. I want the calculator to tell me what angle has an opposite over adjacent of 20 over 100. So I inverse, type that into your calculator. It says that angle is 11 degrees, 11.3, not safe. More than 8.5. Number 6, select all true equations. So we have found out that on a right triangle, the cosine of one angle equals the sine of the angle that's complementary to it. So for example, 40, I'll do an easy one. That's going to be the same as the cosine of, I don't know why I put parentheses around the sine, right? The sine of 40 is the same as the cosine of 50 of the complementary angles. Okay, so here, do 37 and 53 add up to 90? Yes, so the cosine of this one would be equal to the sine of this one. Tangent, that does not hold true. It's just sine and cosine. Sine of 37 is equal to the cos of 53? Yes, those add up to 90, and you've got sine and cosine. The sine of 37 equals the sine of 53? No. It has to be the sine of one is equal to the complement of the cosine of the other. And it says the cosine of an angle is equal to the sine of 90 minus that. Yes, that's exactly what that is, right? The cosine of 37 is equal to the sine of 53 is 90 minus 37. That's basically the rule. Number 7, Claire is flying a kite. She gets tired, so she stakes the kite into the ground. Okay. The kite is on a string that is 30 feet long. Here's the, and makes a 27-degree angle with the ground. How high is the kite? Oops, I drew that a little too big, but that's okay. Here's the ground. The string of the kite is 30 feet. Yes, yep. Making a 27-degree angle. How high is the kite? Well, with 27, we've got opposite, and this, the string, is the hypotenuse. Which trig function uses opposite and hypotenuse? Sine. The sine of 27 is, I don't know, over 30. Put a 1 under this. So I've got x is equal to the sine of 27 times 30. Go to my calculator. We've got approximately 13.625. All right, last one, number 8. What is the length of the diagonal? So it doesn't really matter which triangle we look at. I'm going to look at this one right here. This is 4. This is 4. That's what those tick marks mean. I have a right triangle. And on a square, the diagonal bisects that angle. So these are 45. Well, I don't even need the angles. I don't even know why I'm doing that. Sorry, this is a review question. I would just do Pythagorean theorem, right? 4 squared plus 4 squared equals, I don't know, squared. 16 and 16 is 32 equal to x squared. So x is equal to the square root of 32, if you wanted to leave that exact, or about 5.6. Okay, I hope that helped. Your test or quiz is next week on Monday or Tuesday, depending on what day you have geometry. Have a great weekend.